Welcome back to another episode of Quick Chemistry. In today's video, we're going to take a deeper look at atomic structure, which I covered very briefly in episode 2 of Quick Chemistry, but which we're going to look at more deeply today. Atoms are comprised of 3 subatomic particles: protons, neutrons, and electrons. Protons and neutrons make up what's called the nucleus of an atom, and are hence collectively called nucleons. Protons are positively charged, electrons are negatively charged, and neutrons are neutral. That is, they have no charge. Because protons are positively charged and neutrons are neutrally charged, the nucleus has an overall positive charge. Electrons hang around the outside of a nucleus and are often depicted as orbiting the nucleus, like planets in a solar system orbit the sun. While this is an inaccurate picture, it's one that's useful to keep in mind when you first start out studying chemistry. In keeping with the old opposites attract adage, negatively charged electrons are attracted to the overall positively charged nucleus, which is why electrons can be thought of as orbiting a nucleus. Protons and electrons seem to be the stars of the show here, since they're the ones with the charges and they're the ones doing all of the attracting. However, neutrons are a very necessary part of a nucleus. Just as opposites attract, like repels like, such that similarly charged subatomic particles repel one another. That is, if I put 2 protons or 2 electrons together, they'll try to force each other away, kind of like trying to stick 2 like poles of a magnet together. You simply can't. So, we need neutrons in a nucleus to keep protons far away enough from one another to prevent them from repelling each other, in order to keep the nucleus of an atom intact. You may be wondering why in my diagrams, electrons are so much smaller than protons and neutrons. Protons and neutrons have roughly the same mass. We arbitrarily define this as a mass of 1. Electrons are much smaller, even smaller than depicted on my screen. They have a mass of about 1/1800th of a nucleon and are absolutely tiny, but carry a whole lot of negative charge. This distinction is important when calculating atomic mass, that is, the mass of a single atom. Finding the atomic mass of an atom is incredibly simple. We add up the number of protons and neutrons, which each have a mass of 1, and ignore the mass of the electrons, since they're considered to be negligibly small. So, for a helium atom with 2 protons, 2 neutrons, and 2 electrons, we'll add up the number of protons plus neutrons, 2 plus 2, and ignore the number of electrons, to get an atomic mass of 4 atomic mass units, or AMU for short. If you're familiar with the periodic table, you may recall that decimal values are given as the atomic weights of different species, which would seem to contradict the calculations we've done here today. Note that atomic mass, which is what we've just calculated, is different from atomic weight. The atomic weight values cited for different elements of the periodic table take into account the presence and abundance of isotopes, which is something we'll cover in our next video, so stay tuned for that. And that's all for this week. Be sure to like and subscribe and comment down below if there's anything you'd like to see me cover in future videos. Until next time.